Okay, this is where we are now. This is the third lecture in OSI. The first time, if you miss the 1 and 2, you need to go and find out how we got to this busy chart. It takes step by step to get to this busy chart. So now we are doing protocols today. But protocol is very important. It just means set of rules. Set of rules. If you have millions of computers on the web, we have to have a strict set of rules for them to communicate without getting any confusion. So the way I want to start protocol, I want to start with you so that you'll be able to remember. I go and prove it, then we figure it out. I prove it, then we figure it out. So I'm going to start now on this. Let's go and prove the most important protocol in the world is TCP/IP. TCP/IP is the most important protocol in the whole world. DoD gave it to us. But before we knew about TCP/IP, we had what we call the IPX, XPX. So that one came from Novell. So DoD gave us this. Department of Defense now belongs to the rest of the world now. We gave it to the rest of the world. Okay, so you can see that. So before we knew about TCP/IP, we were using IPX, XPX, because Novell was the beginning of networking like we know it. But since that time, Windows came and took over. So the way you can see this, I'm going to group this like this. So I group them like that. So you see this one starts for T, just to help you remember, this means transport layer. We're going to figure out in a minute. You see, this is network. So you don't have to memorize, just go across, that's transport, you go across, that is network. Okay? But the transport layer, we call it another name. It means connectionless. Excuse me, connection oriented protocol. It means slow but reliable. It's like your special delivery mail in the post office. Special delivery. It takes time, but somebody has to sign for it. So it's very slow, but it's very reliable until somebody gets it. Somebody, they may miss you several times. They continue to come back until somebody signs for it, or lets you go and pick it up. Somebody must sign for it. So it says very slow but reliable. But network is connectionless. What does that mean? It means it's fast but unreliable. Well, it's not unreliable like you think. Your regular mail, the postmaster tried to deliver your regular mail, but there's no guarantee. Something may happen. The little truck may tilt over, drop all the mail by the roadside, whatever. So if you go and say, well, they did not, if you go to the postmaster and say, well, they did not get my mail, postmaster will say, well, sorry, we try our best. You don't have any recourse. So that's the reason why there's some traffic, they are connectionless. There's some traffic, they are connection oriented. So we're going to go and figure it out now. So over here now, under transport, I put TCP, XPX. Under networking, I put IP, IPX. See, this is how we're going to fill up the whole thing in just a minute. Just bear with me. There's something called broadcast. So we are going to another protocol now. Broadcast. It means message to everybody. So we pin. We can pin somebody. Okay, that means we send a particular message to somebody. Okay, So you can pin now. Let me make us an address 192.168.1.200. So that's maybe Joe. We pin Joe. So the protocol is pin. The protocol working behind pin is ICMP. I wanted to know pin ICMP. Then we have, if we don't want to send message to everybody, we can multicast, which is message to group of people. Message to group. Okay, there are times when we don't want to show the baseball game to everybody. We only show it to a group of people. That's multicasting. So the protocol behind multicasting is IGMP. So we have done so many protocols now. Let's go and fit it out. So they are the ICMP is a network layer protocol. IGMP is a network layer protocol. PIN is a transport layer protocol. Okay, so then there's something now which we use to, and bring this back again, something that we use to resolve IP. We have the IP in the network layer. We have the MAC in the data link layer. So there's something that can match them. It's called ARP, Address Resolution Protocol. So we're going to do ARP